Hi there. So the purpose of this recording is to give you an introduction to Modelsim Simulator. The first part of the tutorial will be on simulating a design in Modelsim to generate a simulation output in the form of a list file. The second part is to generate an input trace for the simulator for the design, using which you can get different simulation traces. And the third part is to use that .list output file which you generated in the first part to run a miner. The miner will be generating assertions. The prerequisites for this tutorial are access to two repositories, GitHub repository. DDP simulation is the first one and DDP bug localization is the second one. First one is sufficient if you are just going to simulate the design and not going to run the miner. So in this path, DDP simulation finish help simulation Modelsim, you will find a readme file with all the instructions for a beginner in Modelsim. See, if you open it in the browser, you will see it in this format. So the first step is to install Modelsim either in a local PC, or you can run the Modelsim always from VLSI lab. The second part is to go into that. I will be discussing this part here. I will be going into this 4 counters design. I'll open a terminal from this repository, from this folder, and then you should be connected to IITB network. I'm just going to check it with a ping. So I'm connected. Now you can open Modelsim. This is your Modelsim window. Once you open it, make sure that you are in the right directory, because sometimes Modelsim opens with the previous directory, opens in the previous directory. So pwd is the command to check the directory. So we are in the 4 counters directory. You can list all the files. You'll see that there is a TCL file, sim_counters.tcl. I'm just going to open it externally. 4 counters sim_tcl. Okay, so in this one, okay, I'm just going to open it again. So most of the steps are self-explanatory. It's stopping the simulation first, and then we are defining a directory variable, which is the current directory, because it's just a dot, and then you're opening a project with the name counters. If you get an error at this stage, it's fine, because it's not necessary to create a project. And then you're compiling all the .2.v files in the directory design and its test bench, and this is the wave file which you want to load. Wave is just a setup to show different different signal in the form of waves, which is like value of the signal over different clock period. And then you can just run this command. This command will run the simulation, and this is where you want to decide which all signals will go into the output list file which you are going to generate. And then this is where you are going to write that list file, and the name of the list file is going to be counters.list lst. So at the end of this exercise, you should be able to see counters.lst file here. Right now you won't see it here. I have deleted it. To run the simulation, all you need to do is source simulate sim_counters.tcl and click enter. You can see that there are no errors which should have appeared in red color here. So let's go back to the folder and see we have the list file. If we have the list file, yes, we do have the list file. We can open it and see. So at the top, we'll see that all the signals which we have mentioned in the .tcl file here, all of them are appearing here, and these are the clock cycle at 10,000 picosecond and every 10,000 picosecond intervals, and these are some delta intervals. You don't need to worry about it, and these are different values of these signals at the top for this clock cycle, and so on, and you have up to 80,000 clocks. First part of the tutorial is done. Now you know how to simulate a design in Modelsim. Like we discussed in the beginning, second part is to show how to generate different files along with .lst file which are required for running the miner. For that, I am going to go to another example which is in the same repository DDP simulation in USB folder. So here you'll find different TCL files which are to simulate different designs. For the time being, I'm going to take USBF_PE module and open the TCL file corresponding to that. As you can see, it's pretty similar to what we saw in the toy example earlier for the counters design with some extra additions. You can go through it. The key part is where we write the command for writing these signals to the .lst file. Now you can see that there are, starting with line 92 to 113, these many signals are there. So this generated a list file which we saw earlier. Now we need to copy this. Go to DDP bug localization folder, finish work cart in list USB_4. USB_4 is where we run miner for the USB_PE module. Ideally you should be copying the list file from DDP simulation USBF_PE. So this will come only after simulating the design that I'm not showing in this step. You need to copy it from here and paste it here. That's the first step. And then you can see that there are two files. These two files are already generated, but ideally they are generated in this way. Open this file. Ideally this will be empty. Let's open this one first and then paste whatever you copied from the TCL file. Sorry about that. You simulate USBF_PE, copy everything from here, copy, come back to my list and paste it here. There's barely any difference. There is only this slash, backslash is there. You need to delete it. Okay, that's it. And how do you generate CUI file? You can copy all the contents from here, paste it here, delete. I'm deleting the existing content, paste it here, delete the first two lines, which are the lines for clock and reset, and you're done. That's how you create CUI file and mylist file, and then this .lst file which we copied from the simulation folder. That's it. Now this was step 3 on how to run miner using the list file. Now it's a step 2 where you generate different traces for simulating USBF_PE module. This is present in DDP simulation finish help simulation USB script and generate trace USB_PE_bench.py. So in this script you can it's a small Python script where you write different traces where you generate different in.txt. Actually it's in underscore whatever module we are dealing with .txt. So this is one version. This is done for USBF_PE. Similarly, a more generalized one is present in the Modelsim 4 counters script folder where you see generate_trace.py. So this is a core part. So there was some hard coding in the USBF_PE bench based on the design. It's not necessary. In fact, this part is sufficient. You can actually randomize all the inputs like we have done for the 4 counters. We are done with all the 3 steps. Thank you for watching.